For more than 100 years, airplanes have stitched distant lands together, turning once impossible journeys into everyday travel. Yet beneath the glossy photos of winged giants and the thrill of flight, there's a quiet truth most people never think about. The core technology that drives modern aviation isn't all that modern. For decades, the basic mechanics of commercial aircraft have remained largely unchanged. Jet fuel still roars through engines, pumping carbon into the upper atmosphere. The engines themselves thunder across runways with the same deafening growl. Tickets remain pricey, airline experiences remain stressful, and the process feels like a relic of a previous era. Humanity has advanced almost everywhere, yet flying, in many ways, has been frozen in time. All of that might be about to shift. Elon Musk, the mind behind Tesla, SpaceX, Neuralink, and more than a few disruptive innovations, has stepped into the aviation conversation with a declaration bold enough to tilt the industry off its axis. Musk revealed that Tesla is officially moving into aviation. It's not with a custom jet for billionaires, but with a fully electric aircraft designed specifically for everyday passengers. According to him, this isn't some distant concept meant to stir headlines. The aircraft is already in development, and Musk says it could be taking its first real flight as early as 2026. This new machine isn't just another plane with a battery swapped in. It's a complete rethinking of air travel, rebuilt from the ground up. Tesla wants this aircraft to be entirely electric, totally silent compared to traditional jets, emission-free, and tuned for mass mobility rather than exclusivity. Musk's bigger idea is to transform flight from an expensive privilege into a normal, widely accessible mode of transportation. For the first time, flying clean, flying smart, and flying affordably might actually become a global standard. Central to this new aircraft is the power source lodged inside it. Tesla plans to use its next-generation solid-state batteries, technology that promises seismic improvements over current lithium-ion cells. These new batteries are lighter, denser, more stable, and far more efficient. Traditional jet engines must guzzle fuel to maintain lift and forward thrust. But a solid-state battery-powered electric motor operates with almost silent precision and far less complexity. In Musk's vision, these batteries allow the aircraft to travel somewhere between 500 and 600 miles in a single flight. That range might not cross oceans, but it effortlessly covers the majority of daily commercial routes around the world. Most flights from business travel to holiday trips fall within this range, meaning Tesla's design could handle a huge chunk of global air activity. But what truly sends shockwaves through the aviation world is one of its defining abilities. Musk says the aircraft is being engineered to take off and land vertically. Vertical takeoff and landing rewrites the geographical map of aviation. No more dependence on vast airports carved miles outside city centers. No need for extensive runways or huge tracts of land. With vertical mobility, the aircraft could operate from compact areas that traditional planes simply can't use. Cities could build smaller electric airports closer to the public, cutting out the long, exhausting airport commutes that drain travelers of time and energy. A journey that used to involve hours of ground travel before the flight even began might shrink to a fraction inside the aircraft. The transformation is just as dramatic. Everything from navigation to flight adjustment to landing will be assisted by Tesla's sophisticated artificial intelligence systems. The aim is to eliminate as much human error as possible. Conventional planes require human pilots to operate massive, complex consoles filled with switches, levers, and layered procedures. With Tesla's approach, the aircraft becomes a giant airborne computer, constantly analyzing conditions, reacting instantly to environmental changes, and guiding flights with precision. Musk envisions a level of automation that makes flying safer, smoother, and far less dependent on human reaction speeds. In many ways, it mirrors Tesla's automotive philosophy. Let intelligent systems handle the complexities so humans can focus on decision-making and oversight. One of the most disruptive aspects of this new plane is its projected cost of operation. Musk claims that by removing jet fuel, removing traditional jet engines, and simplifying the entire mechanical structure, Tesla can cut operational expenses by up to 70%. Jet fuel alone represents a massive share of airline operating costs. But electric charging is dramatically cheaper and far more predictable. Maintenance becomes simpler too. Electric motors have fewer moving parts. There are no combustion chambers, no turbine blades, no fuel pumps, and none of the notoriously expensive components that require constant inspection and replacement in modern jets. If airlines can dramatically reduce maintenance, fuel, and logistics expenses, then the savings trickle down directly into ticket prices. That's the part Musk emphasizes most. This isn't innovation for the sake of spectacle. Tesla wants to make flying something the average person can afford regularly. Students, families, low-income passengers, small businesses, and everyday travelers could finally access routes and schedules without budget strain. Air travel shifts from being a special event or a costly necessity into a common form of mobility, much like riding a bus or train in a well-connected city. These changes don't just affect technology, they alter society. They break down geographic barriers. They allow people to move, explore, work, and live more freely. Affordable flying democratizes the sky, while Tesla paints this futuristic vision. The current aviation giant Boeing appears to be lumbering through prolonged turbulence. Over recent years, Boeing has faced a string of challenges that have damaged its reputation, shaken consumer confidence, and slowed its momentum. The tragedies connected with the 737 MAX, caused by faulty software and design missteps, marked one of the darkest chapters in the company's history. Fleets were grounded, investigations dragged on, lawsuits multiplied, and the fallout echoed through the entire aviation sector. The public, once trusting by default, began questioning Boeing's reliability. Engineering errors that once seemed unthinkable found their way into the headlines. At the same time, critics argue that Boeing has been too focused on reacting to crises rather than pushing the boundaries of innovation. While the company works to fix past mistakes, the rest of the world is beginning to eye cleaner, quieter, and more efficient methods of flight. For decades, Boeing held dominance by refining and perfecting the same basic formula. But in an era of rapid change, refining isn't the same as revolutionizing. Boeing's business model depends heavily on traditional jet sales, long runway infrastructure, and older propulsion technologies. And while Boeing has announced interest in hybrid concepts and alternative fuels, few of these ideas have moved from concept to prototype with the speed or clarity needed to establish leadership. Tesla, by contrast, is stepping into aviation unburdened by legacy constraints. Without decades of existing aircraft designs, supply chains, or business models to maintain, Tesla can start from a blank page. That blank page allows bold risks, unusual ideas, new shapes, new systems, and rapid iteration. The same strategy Tesla used in the automotive world, start from scratch, prioritize innovation, and scale aggressively, now sits at the core of its aviation strategy. Tesla intends to treat aviation as a technology problem, not a tradition-bound industry. It approaches flight the same way it approached cars, by stripping away what doesn't work, simplifying what can be simplified, automating what can be automated, and maximizing efficiency in every place it can find. The implications of this shift ripple outward. If Tesla succeeds, airports could shrink, flight paths could change, city planning could evolve, and nations might rethink their transportation grids. Vertical takeoff crafts powered by silent electric motors could create air corridors over cities, connecting people in ways that feel closer to science fiction than today's noisy, fuel-dependent aviation. Quiet aircraft mean flights near residential areas generate less disturbance. Electric charging infrastructure could plug directly into renewable energy grids, transforming aviation from a major carbon source into a sector nearly free of emissions. A world that has struggled to cut carbon from air travel could suddenly find a viable path forward. Passengers, too, would experience travel in entirely new ways. Boarding a plane may feel more like stepping into a high-tech pod rather than a roaring metal tube. The cabin might feel calmer without the constant hum of jet engines. Vertical takeoff could mean the plane glides upward like an elevator rather than roaring down a runway. Automated navigation could smooth turbulence and optimize routes in real time. Instead of worrying about delays caused by runway congestion, passengers might enjoy more direct flights from smaller terminals located closer to cities. For airlines, the benefits stretch beyond cost. Maintenance crews would face fewer complex repairs. Schedules would stabilize because electric engines are less prone to unexpected failure. The simplification of aircraft systems could make airlines far more efficient. With aircraft operating more consistently and spending less time out of service, airlines could run denser schedules, opening more routes without needing more planes. This efficiency could reshape the economics of airlines themselves. Smaller regional carriers might flourish instead of sea.